Here in Ann Arbor, Michigan, some 3,000 cars are equipped to talk to each other thanks to the nation's largest, most comprehensive smart vehicle pilot.
We are actually doing it with real drivers, their personal vehicles.
There's also things like buses, police vehicles. I think we want to equip as many vehicles as possible that run through that area of town.
It's just also the only model deployment of its kind that's testing safety applications.
And safer roads is a big deal. 38,000 people die annually in car accidents and 2.2 million are injured. Especially with moving emergency vehicles through traffic. Things like where you could get notified before you hear a siren that there's a fire engine coming down the street. I think that there's a lot of value there.
Making this project happen are players not only at the University of Michigan and the city, but also the state, the federal government, and 8 auto manufacturers.
Now I think they're looking at technology where the cars are smarter. They're reacting to other cars, sending out messages, hey, I just hit somebody. You hear that, you may get a bump in the seat that says, hit my brakes. And now you're not the guy rear-ending the guy that just rear-ended somebody else. The main purpose of this really is to test the vehicle-to-vehicle manufacturing technology. The second thing is it's called vehicle-to-infrastructure or infrastructure-to-vehicle technology, where we're transmitting information from our environment to the vehicle. So it could be things like temperature of the road, how much rain's falling, things like that.
All of these entities are working together to make the most of the technology and the data derived from it.
Some of the vehicles are more heavily instrumented. So there's about 164 that have cameras and very advanced data acquisition systems on them, where we're collecting all kinds of information about when the driver touches the brake pedal, whether they steer in response to a warning, whether they were looking away from the scene and that's what precipitated the near crash event. So a lot of very detailed data in a limited number of vehicles.
That the information that's being collected is not about Dan Rainey driving his Acura. It just says this certain model vehicle is traveling this speed at this time, is experiencing these conditions. So it's all very high level and not at all tied to a specific person. And if the technology tests out to be viable through this pilot, it will become commonplace in cars.
Experts say that within 5 to 10 years, we could see these systems reach our roadways. For more on this and other innovative technologies, check out the December issue of Government Technology magazine or visit us online.